Hello everyone, welcome. I am Rohit Wadhwa and I am excited to share my research on AI-driven predictive workflow integrity for resilient event-driven enterprise systems, which is called as PWI. In simple terms, this is how through prediction and through automation you can actually predict the behavior of your system before actually disruption happens on your business and also revenue. So we'll discuss more in details about this on the PWI. Enterprise system in AI era. Modern systems highly rely on event-driven microservices, which are loosely coupled, independently deployed, and can be vastly modernized. And they run in multi-clouds as well as edge infrastructures, which are also AI enabled. These are actually highly scalable, but it can actually be very complex and can anchor mass disruption in terms of scalability, in terms of cost, optimizations, and all. And this is where PWI comes into picture, how we can make this highly resilient, which we will discuss in future slides. The reliability problem. So as I mentioned, we are in microservices world, which is highly complex environment and infrastructure. What the reliability problems that we face in our traditional approaches as of now? Definitely, we have latencies that comes into picture because there are multiple microservices that interact with each other. So dependency failures can also arise apart from latencies. It can have a complex workflow dependencies because each workflows are tied to each other in terms of microservices. And even if one workflow gets eroded or failure happens, it can have a cascading effect on entire cycle. Due to high volume, it can create a signal noise. Infrastructure degradation can happen. Also, in terms of your CPU memory, it can actually cause a massive disruption. Geographical latency violations can also happen because we have services running all across the globe and also the users are all across the globe. So in case of there is any geographical issue in terms of geographical location, DR is down, it can actually impact your latency, and also users can get impacted, the business can get impacted because of these latencies, because of geographical locations. And also limited workflow level visibility is there in our traditional approach, which we'll discuss in the future slides. And the failures often can actually increase your revenue. It can breach your SLAs, and it can definitely impact your customer experience because customers are the main motive that we run our operations. So this is of optimized use, how we can make our microservices world and highly distributed systems more scalable and more resilient. All right, so the limitations of traditional monitoring. What current tools monitor? Definitely, current tools monitors your infrastructure metrics in terms of CPU, memory, disk, network. But these are actually the things they monitor, and in case of any issues and or any alarms, we do create an incidents and we do triage those incidents. What if CPU has exceeded your 95% or memory has exceeded your 90%? Then we as engineers or SRE or the developers, we do take care of optimizing this, but we are too late in the game because the disruption has already occurred. Some of your revenue, some of your customers has already started getting impacted because of this spike in CPU or memory. So this is what traditional tools currently do, which are helpful but not at great extent because some of the impact and disruption has already happened at this stage. Service availability, yes, we monitor the uptime. We do check the health checks. What if the service is degraded or service is not available? Yes, we can always restart, we can always bring up the services and resolve those. But again, as I mentioned in the first point, disruption has already occurred at this stage. Um, and also, finally, threshold alerts. Yes, we can have some thresholds triggered on above points, services availability, your uptime, your metrics, CPU memory, and all these things. Your 4xx errors, your 5xx errors, whatever. You can have some metrics and you can create a threshold alerts that can give you an X matter alerts or kind of alerting system, which will actually, bring up all the SREs and engineers into a call to triage and fix those issues. But all these are actually more on a reactive based rather than predictive based, because you are reacting to an outcome, you are reacting on an issues that have already occurred. But these are not predictive that you can predict in first place and can help reduce the impact or even not have the impact in first place. So this is one of the shortcoming that we have in traditional monitoring at this stage. Definitely we do get some false positive. There may be some incidents, maybe your system is operating at night time where the customers are very less usage, on the customers. Maybe you are running just 2 or 3 workflows at late night or early morning, and out of 3, there is a short burst of latency or a 4xx error happened or a retry happened. That can cause some issues. But since you are running just 2 or 3 workflows and one workflow got impacted for short duration, your overall percentage of errors became 33% or 66%, right? And that can give you a false error rate alarm, which eventually it overcome because of retries, and after successful retry it might have automatically fixed it, but you do get false positive alarms as well. This is also one of the shortcoming. And of course it can be slow and more error prone because it requires some manual outcome root analysis by the SREs, by the engineers, by the developers, by the product and everyone. And also there is no infrastructure workflow level visibility, in terms of we are just looking at what the system incoming and outgoing request is. Okay, the system is working well or not. We are just relying on 2xx or 4xx errors, but we are not looking deep within the workflow how each systems are interacting, how each system latencies are working, what's the uptime, you know how the internal systems are working, are we predicting any issues in first place. So these all are some of the limitations that we face in traditional monitoring. And once we discuss more on PWI, we'll see how all these shortcomings are getting enhanced or fixed. That will help us move forward. Coming to the next topic on research objective. The main objective of this presentation here, the opportunity that I got is on my research is how workflow integrity can actually help overcome these issues. Workflow anomaly prediction, that it can actually predict any anomaly in the system in the workflows altogether, and actually it can detect the degradation of the system before actually the disruption happens. Second is autonomous incident management. So we have an AI-driven triage system that uses some machine learning as well, to detect and train the system that helps you discover issues very early in the system, and also auto heals and self recovers the incident, so that the engineers and engineering team can actually focus on improving the architecture rather than just looking and managing their time on fixing the actual incidents. And third is intelligent routing. So we have also in my research enabled an intelligent routing system which is called a geolocation ring based routing, on how rings are basically nothing but how we have different regions, the service is launched into different regions based on proximity based routing. And if your any of the region or recovery region is down, it will help you disaster recovery to a different healthy region basically. So DR recovery is also taking place as of intelligent routing. And also where the users are, the system is hitting that geolocation, so that latencies also get minimized. Like if your user base is more on the east coast, you don't want your systems to be running in west coast, and through west coast your users are through the services are getting the response. It can cause latencies with this event driven microservices, which is highly distributed and scalable. So we want to make sure your routing is based on ring the proximity to the user or the person who is using your application or service. Finally, self-healing operations. As I mentioned, incident troubleshooting is one aspect, but how we can self-heal the issues which could have occurred and which could have impacted your revenue, your disruption could have happened, how you can predictively analyze through automation, through AI and models, and how you can rectify or self-heal the operations before actually impacting any of the user or associates or uh, any of the revenue dollars impact. All right, so coming to the framework overview. So three integrated components that I have formed as a unified AI driven resilient enterprise system. One is predictive workflow integrity, which is called as PWI. So think of in a layman language. Suppose you are baking a pizza. So what we do in our typical steps, right? You dough, you create the dough, and you put the pizza in an oven. And once the pizza comes out of the oven, suppose you see it is already burnt, you know you have already made this entire process, and final outcome is burnt pizza, which has already impacted and the customers. Now what PWI does is it will auto predictively define, okay, are the temperatures at scale what the pizza is required, is the dough correct, does it has more water or less moisture. It will also check internal systems in the oven, if everything is working fine or not. So it will, before even oven gets pizza gets into an oven, it will identify and detects everything. And in case anything is outdated or having some issues, it will try to fix it as well. So you don't get a burnt pizza in first place. Your systems is up and running fine with all the workflows intact and integrated well. Second is autonomous incident triage. So we'll discuss this one more in details, but we have an AI-driven root cause analysis tool, and we have a causal graph correlation that collects different metrics in terms of Grafana, OpenObserve. You collect the different traces through the trace IDs between the different microservices and creates a graph. And based on that, it automates the recovery and provides a recommendation in timely fashion as well in case of any of the workflows are impacted or your system is not up to date. And third and finally is ring-based geolocation routing. As I mentioned, we run our systems both on edge and cloud. If edge goes down, you have to route your traffic to the cloud or vice versa. So it does provide a regional based routing along with optimized distributed workflow, as I mentioned earlier as well. You want your users to be using your services and your product near to the location they reside, so that you are not creating or incurring the latencies and outages. And also, in case of your system or the entire region is down, it should automatically have a disaster recovery to go to a nearby region which is highly working, scalable and available. All right. So coming to the first topic on predictive workflow integrity. Um, so definitely it helps you monitor your workflows to the correct state so that your all the workflows are giving you a good positive signal. Your infra is highly available. All the systems are healthy, giving you 200 OK response, um, and there is no lag in between. Um, so PWI basically it corrects any degradation if your system has your infrastructure is down. It does create the alerts in first place before actually the infra is going down, and that helps you reduce the mean time to recovery as well if your system is reducing or degrading. Um, why it matters, this is one of the most important point, because your system can be up while workflows can silently degrade. You can get 200 OK. Suppose you have a system where all your services are running fine, but the customers are not getting the product because your payments are getting declined because of some data issues, data mismatch between the users credentials or the credit card and all, right? So all the services are up, but there can be a data issue. So PWI does help that, which traditional models does not. Workflow modeling and prediction. So workflows models continuously keeps on learning the workflow behavior. So we have machine learning that keeps on training the models, that detects, okay, how what the workflow usage is, what's the workflow intention is, and what their response and request should look like. And if there is any divergence or any timeline issues, and if it detects any interdependent patterns are mismatching, or deviating from the baseline it has been trained to, it detects that early and triggers an early degradation alarm. So your dynamic state machine, it captures all the state transition and execution paths which are required. Dependencies graphs, basically your inter-service connectivity, how it's working, how the request response looks like, relations looks like in between. If any of the system goes down, it triggers an alarms and auto tries to fix that service, because it can eventually lead to a cascading effect and cause your entire workflows or system to be down. And of course the temporal patterns, if there is any baseline timing impact, it does rectify that as well and ring an alarm early in the stage. Workflow integrity violations. So PWI basically identifies 6 categories of hidden failures, which are actually invisible to the infrastructure level monitoring. Delayed convergence. So all your services are running fine, all your workflows are running fine, but the expected output is not up to speed, because there can be some delayed latency between the workflows that can actually impact. And in a highly scalable systems like microservices, which are highly complex systems, even small amount of latency between one system to the other can actually cause an issue, you know can actually impact. Execution drift. Of course, if your workflow is intended to check the temperature of your oven of the pizza, right? If it's deviating, it's not checking the high temperature, rather it's just checking the low temperature. It's a deviation of the process. So if there is an execution drift, PWI will check that and try to fix that, and also trigger an alarm early in the stage. Ownership conflicts. Okay, there can be a system machine where 2 or 3 different systems are trying to use a common third party service or library, and it can lead to a ownership conflict, where multiple services are trying to reach to that common thing, and the state is mismatched. So PWA also looks for that violation. uh, Temporal sequence, yeah, of course, out of order event uh, process can actually corrupt your workflow state. So it does help look for this anomaly as well, violation. Or fund transactions. If one of the process or instance is not being orphaned, not being used, it will try to see the state of that machine. You can take an example of one of your instance is not being used for some time. It will see, is it down, or is it lagging, or some latency or whatever. It will try to reboot. It will try to check, make a health pin to that health check, and make sure the instance is up and running and also utilizing that. State synchronization inconsistency. Your cross services divergence can actually cause a data corruption. And as I mentioned, even if all your services are running up and running fine, if there is a data mismatch, it can actually lead to a potential disaster. So all these, the violations, PWI keeps on checking these hidden failures before actually the massive disruption happens, and try to overcome and rectify those before time. All right, so autonomous incident triage. So there is a term called telemetry explosion problem. So the main intent of this is, in our system, we collect different logs, you know, through OpenObserve, through Splunk. We send the telemetry events. We capture the metrics in terms of Grafana or some other tools where we can get the CPU, memory, the health check 200, 400, availability of the system, the pods, running state, and everything. Traces, we provide the trace ID between each microservices that is interacting with each other, so that we can actually trace the entire journey, user journey of the workflows all together using a common identifier, trace ID. And of course, the workflow events, that each workflow we should log, like workflow A, workflow B, workflow C. How we are logging is through an enumeration, through the trace IDs correlating to each other, and of course collecting the graphs, the metrics and logs, all aggregated together. Manually we can't achieve this. It will be very slow, complex, and actually error prone. So once we have all this data, metrics, logs, and traces combined together, it can actually help you reduce the incidents in first place. All right, so now comes the causal intelligence graph, which is called a CIG. It's kind of a artificial intelligence analytic core that collects the different traces, the metrics, the workflow events, the service dependencies between each other, your application logs, so your historical incidents which you have faced issues, all these, CIG collects and creates a graph so that it can live streamingly, continuously keep on checking your system, how your systems is running. And it does not even just detect that, it also helps you to fix those, auto heal your process in case, based on all these live streaming, the graph is mismatched, it's not working fine. It will try to identify the multi-hop causal chain across the services, predict the root cause before the incident declaration happens, and surface historical precedents for the faster resolution. So basically, this has transformed into very prioritized incident narrative. Actually, the incident team, along with developers, they can actually focus on the actual work rather than just fixing and monitoring their services, and taking an action on incident troubleshooting. All this is done through an AI system using CIG. It helps to predict, fix, and determine the impact before actually the issues have occurred through the graph, CIG. Next is autonomous incident lifecycle. So AIT is fully automated, AI-driven incident pipeline So it first detects your anomaly, signals. If something is wrong, it will early detect your issue. It will classify the incident severity, whether it's highly severe or low or medium, what kind of severity it has. It assesses based on the severity and the root cause and the impact it has. And based on the severity, if any impact is there, it responds. It remediates and auto recovers, basically, I would say, your system. Um, and also, as I mentioned, if there are 2 or 3 different issues that it can occur or it can, analyze, it will try to do the highly impacted, the critical severity issue first, so that the disruption is very less. Um, Ultimately, the aim is our SRE activities should go on smoothly, without customer impact, without dollar revenue impact, and business impact. Um, so outcome of this is dramatically faster mean time to mitigation with minimal human intervention required, and it reduces the overhead to SRE teams, as I mentioned. All right, so next is ring-based geolocation routing. So we have a three-tier architecture. One is edge ring, um, with a low latency user proximity based, near to the users. Regional ring is more on load balancers, how the load balancers is routing the traffic to different regions based on the proximity of the users and the services. And the final is global ring, which is more of the orchestration consistency cross region, and that helps you disaster recovery if your entire region is down. um, so this actually helps reduce the latencies, keeps your system available up and running every time in case of any failures or any disruption, and workflows continue executing resiliently during your regional disruption by routing the outer regions. All right. So based on all these, the AIG, the graph, the PIW, we have figured out, these are our experimental results. Our mean time to detection has significantly reduced from what traditional used to give 12 minutes. Now it's less than a minute, and in most of the cases, there is no disruption at all, because PWI, with the AI help, helps figure out the issues before actually issue occurs in first place, and auto heals or remediates itself. So this has significantly reduced, the MTTR. Uh, Mean time to mitigation, of course, significantly reduced, because there is no dependency on actually the operators. Rather, the system is taking care of its own. False positive has reduced a lot, as I gave an example earlier, because there can be a system or an instance where you do get false positive actually, but the issues are not there, and because of retries, your circuit breakers and all, the issues have already been working fine. But if you get a false positive in traditional world, you keep on troubleshooting that issue, which never happened. And of course, edge to cloud latency, it can happen because you manually used to flip from edge to cloud if edge is down, or vice versa. PWA does take care of automatically flipping your systems from edge to cloud or cloud to edge. That has also optimized to a great extent. So the final conclusion and future direction, of course, PWI is a workflow centric, forward looking observability model with AI that helps you predict the failures before they actually occur and impact your system. Autonomous Incident Triage AIT is an AI-driven multi-signal system that helps you automate and recover your incidents triaging. Causal Intelligence Graph CIG is a unified telemetry intelligence layer that streams all your metrics, logs, observability things, creates a graph, and if it sees some mismatch or misalignment, it fixes that. And ring-based geolocation routing, which is proximity-based routing where your services are running to the end users, and also the auto data recovery also takes place with that. Um, some of the future research directions that we are also thinking to improvise are listed here. How we can federated workflow intelligence across organization boundaries, some AI governance, digital twin simulations, cross cloud workflow integrity verification. So that's a future enhancement that we are planning to build more onto that. um, um, yeah, so thank you first of all, and before we finish, a couple of Q&A. The first is, how can AI driven predictive monitoring improve the resilience of event driven enterprise system compared to traditional reactive monitoring approaches? Yeah, so I think most of this is already covered in the slides, but as I mentioned, in your traditional world, uh, you you wait for the incidents, actually that happened. You wait for the failure that actually happened, and then you start taking action on that. I gave you an example of like pizza, right? So um, you have a system where pizza making and delivery is one of the system. So you bake your pizza, and if your pizza comes out burned from an oven, you have already have an impact both on the customer because they are waiting for the order, and also the material which has costed you, right? But what PWA does is it helps detects all the different, optimization temperature. What is the suitable temperature required for your oven? Is your dough is properly kneaded? The water retention, the moisture in that. So everything it takes care with each workflow, and it auto detects and auto recovers. If your temperature is not up to great state, it will fix the temperature to the optimized state. If the dough is not proper, it will help you fix that by adding more water. And also in traditional world, as I mentioned, MTTR was very high, mean time to recovery, but with PWI, you are not even getting more of an issues because it's auto predictive analysis is done, and auto healing is done. So this is where it's distinct and highly proven compared to the traditional world. All right, so coming to the second one, what architectural and operational considerations are essential for implementing autonomous incident triage and self-healing capabilities in large-scale distributed environments? All right. So I would say, architecturally, you should have your enterprise system with different logs, metrics getting streamed, along with your retries to the systems, along with a circuit breaker if your system is down, how you can prevent hitting that multiple calls to that system until that service or infra is brought up. So architecturally, yes, you can enhance on those things. Operational considerations, of course. So you can have your metrics run to different systems. Your incident triaging through the graph, you can through the automation or through AI, you can actually determine if all your incidents triaging system is in place, and if there is a mismatch on the training done through the machine learning, your graph alignment is mismatch, how it can automatically triage that and fix that in a large distributed scale environment, which will actually eventually help reduce the noise, external noise. Because for us, the ultimate aim is, customer satisfaction, I think, for all of us, right? So in that sense, uh, getting to an incident triaging, rather than having that thing to the extent where you will not have an incident, or even if worst case incident happens, how quickly it can be detected and identified and fixed on its own. So that operational benefit is of utmost importance to everyone. So this is where actually PWI comes into picture, through your operational and architectural aspect, help you fix those and make your system highly scalable, robust, and event driven based. So this is, altogether on my research. Thank you once again. Thank you everyone for the time and attention. Appreciate. And that's all from me. Signing off. Bye bye.